In this video we will have a look into the really powerful 3D modeling method subdivision. And subdivision is normally based on a low resolution model, for example like this one, and with smoothing it just converts into a high polygon model, so you're able to model really advanced 3D models with very few steps. So let's start with a really simple geometry, a simple box. I go into my keyboard entry and I create a box with a length, width and height of 1 meter. Okay, the next thing we do is we just copy this box. I hold my shift key and just move it to the right, and I want to have 3 instances. We'll see why I choose instances later on. I just move these instances on above and to my top view, and these instances will get the subdivision modifier mesh smooth. Okay, here we go. Here we have our little basic cube and our 3 cubes with our subdivision mesh smooth. The first thing we would like to look at is the level of subdivision you create, and what we can see right now is you can see these lines around our ball, which was actually our cube. And the first thing we do is we switch off isolate display, so we can look at this polygon level of our mesh smooth subdivision. And what's happening in subdivision, that every subdivision level divides a polygon surface by 4. So our first cube will have subdivision level 1 iteration, and I just go into make unique, and so it's independent to the other one. I choose the second cube, and I also go into make unique, and I just change the iterations from 1 subdivision to 2 subdivisions, and we see what's happening. Actually, you can see that the thing becomes more smooth, and again the whole thing is divided by 4. So before we had 6 polygons, and now we have 6 multiplied by 4 multiplied by 4 polygons. If I just choose the next ball, I go again into make unique. By the way, I didn't have to do this, it already happened here. So what I do right now is I increase the iterations to subdivisions 3, and you can see that it becomes smoother and smoother, and it's also like this, that it increases the amount of polygons. And if I just go into these settings again, isolate cage, isolate display, you can see that the polygons are now not visible. It's just these little cage around. We talk about this later on, and the whole thing becomes nice and smooth, and it just based on this topology means a simple box. Subdivision always creates faces with 4 edges, means quad faces, and this is quite important, for example, for surface paneling, so that's a really handy thing. What we want to look at now is that there are different kind of subdivision methods or mathematic calculations, and so we have a look at the first one in 3D Studio Max actually, and the first one is this norms method, and I choose my second bowl. I go into iteration 1 and the third one, and go into iteration 1, and you can see the second one is quad output, and the third one is the classic. So you can choose between these different kind of methods, and you can also see that the transformation of the geometry is slightly different, and that these method norms which I normally use is the smoothest actually in terms of these subdivision methods. So let's have a closer look at the relation between the basic topology of my object and my subdivision. I just select my subdivision with my norm subdivision method and my basic object. I go into isolate selection, I move them a little bit closer together, and select all. Now we go into zoom extend all. Okay, I think that's already quite good. And this is my object with my mesh smooth, and what I did is I just copied it as a reference, and you can just see right now that this is quite handy, because if I change my basic topology, means my cube, for example, I add more segments, then you can see already what's happening with the other one. It just has this mesh smooth on top, and you can see the impact on this geometry. Obviously I can also work in this geometry, but I think it's quite nice to work on this like this, so we can compare in a really quick way what I'm actually doing. With my basic object, I just increase the length, the width and height segment, and definitely has an impact on my mesh smooth object. And in my mesh smooth object, I just increase the iterations to 3. You really have to take care of that you don't pump it up to 7, 8 or something, because your whole computer can crash. You always have to keep in mind that every iteration on top is multiplied by 4, and so the number of polygons can be quite heavy. So what I also do is I just switch on isolate display again, so you just see my cage around, and so it looks like a really simple geometry again. Okay, we go to my basic object, we go back to my basic object, and I reduce it to length, width and height segments 1, and I will just add an edit poly on top. I go into viewport and extend my viewport settings. And what we want to look at is what kind of impact it has when I change the geometry. We already did it with the segment tool in box, but I would like to use my Swift loop, which is quite handy, because we want to see what's happening if I just go to quite close to my corners, and I just go into Swift loop and add one Swift loop here, and you can see, just do it another one here. You can see what kind of impact my new polygons have on my geometry. This means that we have more or less sharper edges at these sides where I just added my 2 Swift loops. And if I just go into my front view and I just choose my vertex points, I just choose these vertex points. I switch on my 3D snap toggle right mouse click vertex point, then I just move this to this point. Okay, I just see if I selected it properly. Again, I just didn't look too good. Okay, I just move this to these points, and the other ones I moved, just move down here. And then we can see what my mesh smooth object looks like. And you can see that I have sharp corners at these edges, and this means the polygons are just the vertex points are just on top of each other. My basic object doesn't look too good anymore. It should go into properties, and I just choose it again, and I go into hard shade, and then it looks pretty well again. It's a question of shading actually. The quality of the basic topology is really important. There actually should be all quad faces, means every polygon should have 4 edges, not 3, 5, 6, 7 or something like this. And we will just see what kind of impact this has on our geometry. I go into box again, I choose 3, 3 and 3 segments for length, width and height, and I just add an edit poly modifier on top, and we will change the topology of 2 polygons actually. I just go into my snap toggles 3D vertex selected, and then I choose my cut tools via my modifier panel, or just go into edit and cut of my graphite modeling tools. Okay, and I want to cut these polygon. I just switch on my wireframe mode F3, and I should be really sure about that. I really select the right vertex points. This looks quite good right now. I go to this point, I go to that point, and I just cut it in two pieces, and I do the same thing here. Actually, right mouse click and I close my cut function. I go into my shade mode again. It looks pretty much the same like before, but if I have a look at my geometry, then you can see that it's slightly distorted. There are little creases, and it's not so much with this cube actually, but it depends on what kind of geometry we have. The whole thing can look quite muddled up. We can see this even better if I just add a tessellate modifier on top, and we just choose tessellation, for example, like this. I switch off my edge face, and you can see that this is not a smooth cube anymore, and the basic cube still looks quite well. If I switch off my edit poly, it already looks much better, and if I delete my three triangulated edges, then I have a really smooth cube with round corners. The reason for this is that it always tries to build up quad faces, and this is just sometimes not possible if some faces are triangulated. And we look at this again in my basic object, and we have these four triangles inside. And what I just choose is, again, I go into edit poly, and under edit I choose my swift loop. And what you can see is that I can use swift loop with all polygons which have quad faces, means four edges, and you can see that it follows. And always when there is when there are triangulated faces or faces with 5, 6, 7 edges, then my swift loop doesn't work anymore. And that's the same thing with my mesh smooth. You can't quadrify the whole thing, and this means that's not perfect for the next step of mesh smooth, because if I now switch it on again, my tessellate, and choose my basic object, this one, you see what's happening if I change my iteration. This is iteration number 1. It already looks like the basic geometry. I go into iteration 2 and I switch off my isoline cage, and you can see that there's a completely different pattern. And if I just switch my tessellate off again and I look at my geometry again, this is my basic tessellation. You can see these little edges, and you can also see what it does with the next steps. It just builds different kind of topology here, and this means that it also changes a little bit the shape. Okay, let's have a deeper look at my mesh smooth. I deleted my tessellate and my first edit poly, so I have a really clear topology again. And with mesh smooth, you also have a sub-object level. You have the sub-object level vertex, you have the sub-object level edge, and you can see these cage, and you can also just switch on isoline cage, so you can only see this cage and you don't see the real polygons anymore, which is sometimes better. You have a better view on this. And what you can do is you can just, for example, select this group of edges, and you can move them. You can probably just move them in all directions, and you can really reshape your geometry. These points you actually see, they're not vertex points anymore, but they are control points, and you can increase the level of control points. Just switch on control level 1 or 2, and then you have these little dots. You can also go into soft selection and increase the selection with this fall off, and so that's how you have a really good control on the whole shape, and you can really shape it the way you want to do it. If you switch off isoline display, then you can see that that it has an impact obviously on my polygon. And you can also see if I reduce the iterations, then it's obvious that you can't have more control points than iterations. I go now into iterations than polygons. If I go to iterations 1, then it also automatically goes down to control level 1 and so on. So and increase it again. And the next level we look at is the level edge. Okay, let's choose edge, isolate, select display, I switch on again. And contour level I reduce to 0. So what you can do is on level edge, I can just choose these edges, hold my string key and just chose these 3 edges. And obviously you can also transform this like the vertex points, but you can also crease it, and we just see what's happening. You can just crease it back to a corner. You can see it here very well in my front view, and you can also see it pretty well in my perspective. So this is something you can do in a nice way on edge level. The same that you can change the weight. This means how much influence it has on your selection. You can see what's happening. Weight 0, it's only on the edge in the middle, and the other 2 don't have an impact on my crease anymore. So that's also a really nice way of adjusting my my 3D object with the mesh smooth modifier or the subdivision method. One of the most powerful features of subdivision is separating your surface parameters by materials or by smoothing group, and this is something we want to look at right now. What you actually can do is, as a starting point, we can reset the mesh smooth, and I just go to reset all levels. You can just reset the creases or reset geometry edits or reset everything actually, and this is just starting mesh smooth from scratch. Okay, we will slightly change our geometry, and let's see. I will do it like this: one height segment and segment length and width to 1. I go into edit poly, and what I do right now is I just go again into animate, and I choose these polygon, and I will just extrude this polygon, and I extrude by polygon obviously, and I extrude it like this. We can already see it also has an impact on my mesh smooth. I choose, I just call this rename edit poly extrude. Oops. And I will add another edit poly on top, and choose this polygon, and I will then animate, go again into animate, and say I want to have an inset, also again by polygon, to make it a little bit smaller, and name this edit poly inset. I just do it so I can change the parameters at the end. Inset, and add another edit poly on top. I rename this edit poly extrude again. I will go into this poly selection, switch on my animate, go into extrude by polygons, and I will extrude it like this, so it goes a little bit to the inside. Okay, this is my starting point, and the advantage of this animate mode is that I can just go into my extrude on the first level, and I can go up again into my settings. I choose settings for this modifier, and I can still change it, these parameters, and okay, something went wrong here. I shouldn't have changed the selection. I go into this setting and I can change the extrude on this level. I will choose this setting, and what I have to do is I have to switch on show end result toggle on. This was something I should have done earlier too. I go into this setting and I can change the inset here, so it's a really nice way of an easy way of parametric design. Okay, we choose our basic mesh smooth geometry, and the first thing we look at is there are a little bit of you can see the edges and everything, so I will just check my mesh smooth object. 3 iterations look this looks really well. And there's one thing I should definitely switch on smooth results, which I do right now, and then the whole thing looks really nice and smooth again, because I have a proper shading going on. Okay, let's look at this separate the surface parameters, and you have 2 options, by materials and by smoothing groups. By materials, I think it's really handy for games, and you can also obviously separate the smoothing groups by materials. So I just click on by materials, and they more or less all have the same ID at the front, and probably here a different ID. What I really want to show you is separate these surface parameters by smoothing group. This is something really nice, and this is something we want to look up now a little bit closer. I hope it's clear that it's not necessary that I constantly have to work with this reference, but it's a much better way for us to look at this. So I just continue with the references. So that's the same object actually, and I just choose this one and I add a new edit poly. I just call this rename edit poly smoothing groups to make it really clear. And what I have to do is I have to go into the sub-object level polygon, and if I go into polygon, you just scroll down. You can also pull this a little bit to the left, so you have all your features next to this, and there's something like polygon smoothing groups, and that's quite interesting. If I select these polygon, for example, you can see it has no smoothing group switched on, so it's smoothing group 0, and this one has smoothing group 5, and this one is 0, this one is smoothing group 4, and we can just see, if you look at this polygon, which is actually this one, and this one, which is actually this one, that you can see that it's in the same smoothing group. And if something, or if a polygon is in the same smoothing group, it just means that smoothing is working, and it just means that it will be around a nice smooth transition. And if you look at this, the front one, you can see that this is actually in smoothing group number 5, and this already defines a sharp edge between these and this surface. If I choose this one, for example, and I go into smoothing group number 5, then you can see that it already will smooth these part between these and the other shape, and you can just continue looking at the surfaces. If I choose this one, it has no smoothing group, and the one inside also no smoothing group. This also means that's the reason why this is a little bit round, and so on. If I choose this one, then it has a smoothing group, and this is also means why it has a sharp, why it has a clear edge corner. Okay, just for a clear start, I select all my polygons, string A, and I just see that smoothing group 2 to smoothing group 7, here you can't see any numbers, so this means there are several polygons selected. Some of them have smoothing group 2, some of them don't have smoothing group 2. If I deselect them all, which I do right now, then you can see that the whole thing is completely smooth, like the beginning, like the time where smoothing groups or separated mesh smooth by smoothing group was switched off. There's some options to have some preset smoothing groups. For example, if you go into this auto smoothing groups, then you can see that it's related to the angle. There are not many angles right now. There's only this 90 degrees, but it already does something. And there's one thing, it was not really necessary to deselect everything. I can also say clear all, and that means none of the polygons has a smoothing group between 1 and 32, so all of them have smoothing group 0. Okay, what we can do is actually we can just select polygons. Just select this one, hold my string key, and then just select some polygons, and we can just put them into one smoothing group, for example like smoothing group number 1. You can already see what it does. Everything in one smoothing group has a clear edge to smoothing group 0. And if I now select other polygons, for example like these guys, and they will have smoothing group number 2, then you can see that this is also now has straightened edges, and so on and so on. What you can also do is that polygons can have several smoothing groups. For example, this one has smoothing group number 2, and I will just give this one smoothing group number 3, and I will also give this one smoothing group, let's see, number 1. And we can see what it does. It just makes a corner here, and if this one on top also gets smoothing group number 3, then you can see that it makes it round. So there's a really nice way of choosing the smoothing groups, and like I already said, a polygon can have can be a part of many smoothing groups, and you can then really adjust the whole thing in a way you want it to be. For example, I choose this one, and it also has smoothing group number 3, and probably the other two, this one and the one opposite, also will have a smoothing group number 3, and yeah, you can see that this is a really powerful tool of designing 3D geometries. Okay, what you normally will do is you will do everything in one object. So I just choose again my my mesh smooth object, and there's one thing you should keep an eye on. If you go into polygons and change the smoothing groups, you should be aware of, when you select the polygons, that you always select the polygons on this edit poly level. So if this whole shape is distorted in a way that there is a lot of curves happening and things like this, it could be difficult for you to select the polygons. For example, here I wanted to select the top one, and I just clicked on the top one, and I'm completely confused. Why can't I select the top one? It's quite easy. It's just a smoothing. You should always go on show end result toggle off, and then you can see that the real topology, the real geometry or polygon you have to choose is this one. And so it's always good if you select the polygons that you show end result toggle off. If you have problems in terms of selecting, this can cause a little bit of trouble, and that's good if you are able to avoid this. Okay, this was a short introduction, not short, over 20 minutes actually, but into Subdivision. It's a really powerful tool, and a lot of things you can still learn, but I think it's a basic knowledge where you can already do a lot, and everything is based on a low polygon modeling. So with really simple basic object geometries, you can have really advanced three-dimensional shapes for architecture, product design, and every kind of design work. Thank you.